Here are the answers for section 7-8. On page 276 oral, we're asked to change these into standard form. So standard form of a quadratic equation is ax squared plus bx plus c equals 0. The right side must be 0. It'd be nice if a, b, and c were integers, and we want a to be a positive number. So for question number 1, we need to subtract the 4x and add the 3. And now we have standard form. For question number 3, we need to subtract the x squared, getting negative x squared plus 4x equals 0. But one of the requirements of standard form is that the value of a, the value of the leading coefficient, is positive. So now let's divide everything by -1. And here's standard form. Number 5, let's add the x squared to move it to the left side and subtract the 4x. And there is standard form. Number 7, let's add the 3x squared and subtract the 10. Number 9, we don't have things on the correct side of the equals, although there already is a 0. So with the symmetric property, we can just exchange the sides. But another thing in standard form is we don't want to have fractions. So let's multiply everything by 2. Then divide everything by -1 to fix the sign in front of the x squared term. And finally, we'll use the symmetric property to exchange the sides. And here is standard form. Notice in standard form, everything is on the left side and the right side is 0. The terms have the quadratic term first, then the linear term, then the constant term. There are no fractions, and the leading term is a positive number. Number 11, if they are in standard form, identify the values of a, b, and c. So a is 2, b is 2, and c is 5. For number 13, this is already in standard form. A is 5, b is -9, and there is no constant term in there, so c is 0. Number 15, this is as close to standard form as we can get. The value of b is going to be an irrational number, but we don't have a way to fix that. So looking in front right there, that's our a, so a is 1. Looking right here, that's our b, so b is negative square root of 2. And then looking right there, that's the c, c is 1. On page 276 written, we're given some quadratic equations and we're asked to solve them. So solve for x or t or whatever the variable is. But we're told what method to use. In number 1, we have to use completing the square. That means we need to rewrite this trinomial as the square of a binomial. And we have a process for doing that. We have to have this constant term be the correct number for this to be a perfect square trinomial. Let's figure out what half of the -6 is. That's -3. Then square the -3. That makes +9. If we want to have a perfect square trinomial where this middle term is -6t, then our constant term must be +9. So how do we make -7 turn into +9? We would need to add 16, because -7 plus 16 is 9. If we add 16 to one side of the equation, we have to add 16 to the other side to compensate. Now we could rewrite our trinomial as t squared minus 6t plus 9 is equal to 16. The reason that we did that is so that the trinomial is a perfect square trinomial and not a trinomial that doesn't factor as a binomial squared. When we factor this, we get t minus 3 squared is equal to 16. Now we can take the square root of both sides to remove that power of 2. So our work step is we're going to take square root. On the left side, you get t minus 3. On the right side, we're going to do the positive and negative square root of 16. Let's continue up here. So we have t minus 3 equals positive and negative 4, because that's what the square root of 16 is. Now add 3 to both sides to get the letter t alone. We get t equals 3 plus or minus 4. This is actually two different answers. Let's evaluate both of them. 3 plus 4 is 7, and 3 minus 4 is negative 1. Here are the two answers for t that work in the original equation. And the method that we used is called completing the square. Now, number 3, we're also asked to use completing the square. So we want this trinomial to be a perfect square trinomial. So let's figure out what we need the constant term to be. Take half of the coefficient of the linear term. That's negative 4. And then square that negative 4. That's 16. We want this to be 16. So we need to add 17 to both sides, because negative 1 plus 17 is 16. We end up getting v squared minus 8v plus 16 is equal to 17. The reason for doing that is because this is a perfect square trinomial, and it factors as a binomial squared. And the reason that's nice is now we can do square roots. So when we take the square root of the left side, we just get the v minus 4. On the right side, we get the positive and negative square root of 17. Now to get v alone, we have to add 4 to both sides. So we have v equals 4 plus or minus the square root of 17. This is actually two answers. You can leave them in this compact form, which shows both answers together, or you could separate them. One time using the plus sign, and the other time using the negative sign. If you need to get a decimal, you could type both of those problems in the calculator to find the answer as a decimal. Number 5. This kind of looks like standard form, but I noticed that all the terms will divide evenly by 3. Let's do that first, because that's going to make our completing the square a lot easier. We get s squared plus 5s minus 5 equals 0. Now that we have a leading coefficient of 1, let's do the completing the square process. Figure out what half of the 5 is. That's 5 halves. Then square the 5 halves. That makes 25 over 4. That's what we want our constant term to be. However, it's a little difficult to figure out in your head what you would need to add to this negative 5 to end up with 25 over 4. So one way to make it easier is to add 5 over to the other side of the equation. And when you add that 5 to move it over there, leave a blank spot here. Now we can simply add in our 25 over 4 and compensate by adding 25 over 4 on the other side. This is our perfect square trinomial, and it factors as s plus 5 halves squared, and that's equal to whatever 5 plus 25 fourths is. So we delayed having to do a difficult math problem until this point in time, but now we can't get around it. We have to add these together. If I change 5 into a fraction with a denominator of 4, it would be 20 over 4. And 20 over 4 plus 25 over 4 is 45 over 4. Now let's do square roots. So we get s plus 5 halves equals the positive and negative square root of 45 over 4. Then subtract 5 halves from both sides. We get s equals negative 5 halves plus or minus the square root of 45 over 4. But we can simplify that up a little bit. Think of 45 as 9 times 5. The square root of 9 makes 3, and the 5 stays in a radical. In the denominator, the square root of 4 makes 2. So here are both of the answers for S, but put into a compact form using a plus and minus sign. We could separate these out if we needed to see the answers separately. Or if you needed decimals, you could type in both math problems, one time using a plus sign, and then retype this whole thing, but use the minus sign. Number 9, we're still solving equations, but this time we're told to use the quadratic formula. The quadratic formula has as its general form x equals, although in our problem, notice we have the letter r, not x, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This was developed in a lesson. To use this formula, we need to know values of a, b, and c. So let's go to our equation and make sure it's in standard form before we find a, b, and c. It's not in standard form. Let's subtract 1 from both sides. Now that we have standard form, we can see that a is 3, b is 1, right there in front of r, and c is negative 1, our constant term. Let's use this formula, but instead of using x, we're going to say r equals. Okay, it says negative b. If b is 1, then that becomes negative 1. Then it says plus or minus. Then there's a square root symbol. In the square root, it says b squared. So if b is 1, that becomes 1 squared, or just 1. Then it says a times c. A is 3, and c is negative 1. It's all divided by, with a really long line that even goes under this first number, 2 times a. Well, if a is 3, then 2 times 3 is 6. Let's simplify this a little bit. We get negative 1 plus or minus the square root of whatever this makes in here. Let's figure this out. Negative 4 times 3 is negative 12, times negative 1 is positive 12. And a 1 plus a 12 is 13. And this is all over 6. So leaving our answer in compact form, we have negative 1 plus or minus the square root of 13 all over 6. Number 11, before we do the quadratic formula, we have to use standard form. So let's subtract the 5y squared to the left side. We get negative 5y squared plus 8y plus 20 equals 0. And then divide by negative 1 to make the leading term be positive. Now we know that a is 5, b is negative 8, and c is negative 20. So we have y equals negative b. That would be 8. Inside the square root, b squared would be negative 8 squared, which is 64. The letter a is 5, and the letter c is negative 20. And that's all divided by 2 times a, which is 2 times 5, or 10. Now let's keep going on this. We have 8 plus or minus the square root, and let's work inside the square root. To avoid making arithmetic mistakes, it might be easiest just to type this in the calculator. That all turns out to be 464. Now, is the square root of 464 an integer? Let's try that on the calculator. It's not. When I type that in, I get the decimal 21.5. That'd be okay if I want to give my answer using decimals, but if I want to just give my answer in simplified form, then let's try to simplify that square root. With the help of the calculator, I can figure out that 464 is the same thing as 16 times 29. And we can find the square root of 16. So this makes 8 plus or minus 4 square root of 29 all over 10. And this reduces because 8, 4, and 10 are all divisible by 2. So we get 4 plus or minus 2 square root of 29 all over 5. Number 13. This is already in standard form, and unfortunately not all of the terms will divide by the same number, which would reduce their size. So our values of A, B, and C are going to be fairly large. We have n equals negative b, so negative 24, plus or minus the square root. Now b squared, so 24 squared, that's 576, minus 4 times a, which is 9, times c, which is 16, all divided by 2 times a, which is going to be 18. Now let's work out what that is inside that square root symbol. The safest way to avoid errors is to type that in the calculator. You know what? That just all makes 0. So we have negative 24 all over 18, which is a reducible fraction. Top and bottom both can be divided by 6. So we get negative 4 over 3. This is interesting. This quadratic equation has only one solution. The other ones we were doing had 2 answers. Remember that plus minus symbol? So it looks like when the expression in the square root turns out to be 0, that forces our equation to end up with only one possible solution. Number 25, the directions change and they say solve the equation with any method. So we have to figure out what kind of equation we're looking at. Of all the things we learned about this year, what is this? This is an equation with fractions in it. This is the kind of thing where we're looking for a common denominator. The first thing I'm going to do on it, however, is work on this middle term to fix this minus sign and at the same time to fix this here. This 3 minus m will factor as negative times m minus 3. And that negative sign can be multiplied to that negative sign, making a plus sign. So this rewrites as 1 over m plus 3 plus 1 over m minus 3. And that's equal to 2. This will make multiplying by the LCD easier. First, let's find the LCD. It will have m plus 3 and m minus 3 in it. To change this first fraction into the fraction with the LCD, we need to multiply top and bottom by the m minus 3. Because the denominator already has the m plus 3. Over here, to take this fraction and make it have the LCD, we need to times top and bottom by m plus 3. Because its denominator already had the m minus 3 part. Now the 2. To get a common denominator, let's put a 1 underneath that, and then multiply top and bottom by m plus 3 times m minus 3. And then evaluate what this makes. This is 2m squared minus 18 all over the common denominator. In this spot here, notice we can do some combining like terms. M plus m is really 2m, and minus 3 plus 3 cancels away. Because these fractions are equal, their numerators must be equal. So let's rewrite them without the denominators. This creates a quadratic equation, which we can put in standard form. 2m squared minus 2m minus 18 is equal to 0. All the terms divide evenly by 2. So let's do that because that'll make it a little bit nicer. At this point, we have a quadratic equation in standard form, and we can choose a method to use to solve it, such as factoring, completing the square, or the quadratic formula. I'm going to use the quadratic formula and identify that a is 1, b is negative 1, and c is negative 9. So we have m equals negative b, that will become a 1, plus or minus. B squared will become a 1. minus 4 times 1 times negative 9. And that's all divided by 2 times a, which will just be a 2. So we have 1 plus or minus. Inside the square root symbol, it turns out to be 37. And that's all over a 2. So here are our answers for M. Finally, number 31. We're asked to solve this using any method we want to. This is a quadratic equation in standard form. We could try factoring, completing the square, or the quadratic formula. I'm going to use the quadratic formula. A is 5, B is a 1 right here, and C is a 1. So we have x equals negative b, so negative 1, plus or minus the square root. Now in here is b squared, so that makes 1, minus 4 times the a times the c. All divided by 2 times a, so 2 times 5, that's 10. Now let's do a little bit of work inside the square root. 4 times 5 times 1 is 20. And 1 minus 20 is negative 19. This is all over 10. Earlier this year, we discussed that you can't find the square root of a negative number over the set of real numbers. We'll be able to do this when we study imaginary numbers, but at this point in time, we're going to say there are no real solutions. This is when you put empty set, meaning no real solutions.